From here.
Let's see.
Okay, now the next example, right? Example 2. What's the difference between this first one and second one? The difference is that the first one, it was loaded with just a single load, right? It was loaded with just a single load. And the idea, the way you solve that particular beam, when it was loaded with a single load, what if it is loaded with 2 loads or 3 loads of that same nature, which is point load? Same idea works for it, right? And always at the end, your shear force and bending moment must follow that same pattern, right? It must follow that same pattern. Now, for this guy, bending moment diagram, let's say you are given this beam, and the question says that draw the shear force and bending moment diagram. You already know how it works now. It's just like stages, right? You are following a particular stage to get your final diagram. The first thing I'm going to do is to what? I want to believe everybody now. You already understood how it works, so you'll be doing it together. You are going to be doing it together. Now, the first thing is what? What are you going to do first? What's your first thing? You are going to calculate the support reaction, right? Once you've calculated the support reaction, start doing your shear force calculation and bending moment calculation. Then lastly, draw your shear force and bending moment diagram. Now, what type of beam is this? What type of beam is this? What type of beam? This is a simply supported beam. What type of load is this? U.D.L. No. What type of load is this? U.D.L. This is a U.D.L. For the last time, what type of load is this? U.D.L. Now, when we did our last class, we've discussed how U.D.L works. For people that are there, we discussed how U.D.L works. We said when it comes to U.D.L, we have 2 facts about U.D.L. The first one is that you're converting a U.D.L to a point load, right? The second one is that the distance of a U.D.L is equal to the centroid. So we want to apply all these that we've been saying, right? Now, do you know the reason why we are converting a U.D.L to a point load? We discussed that. By definition, what is beam? Just remember what a beam is. We said a beam is a structural member subjected to different types of load at right angle to its axis. Meaning that any type of load your beam is subjected to, it must what? Act at right angle to the axis of that beam. Let's say this is a beam. Let's say you have this being a beam. Though we discussed all this previously. Let's say this is a beam. Say this is 1, 2. Let's say this is a beam. And this beam, let's say mathematically, say this is 1, say this is 2. This is a load, right? This is also a load. By definition, a beam is a structural member acted. A beam is a structural member subjected to different types of load, acting at right angle to its axis. Keyword, at right angle to its axis. Meaning that any type of, for every load subjected to your beam, it must what? Act at right angle to the axis of that beam. Now, let's say this is the axis of your beam, and let's say this is the axis of your beam. I want you to look at these 2 beams, say 1 and 2. I want you to look at it mathematically. Which one is acting at right angle to the axis of the beam? 1, right? Because for mathematics, let's say this is right angle. If this is right angle, I have this as what? 90 degree. 1 is acting 90 degree to the axis of this beam, right? So let's say this is what? 90 degree. 2 is 2 acting 90 degree to the axis? No, it is not acting, meaning you have to convert. So that's the idea behind conversion. When you are doing conversion, it simply means that we want this load that we are converting to act at right angle to the axis of the beam. Are you getting me? So, meaning, given any types of beam different from a point load, you do conversion. It is a must. You do what? Conversion. You do conversion. Now, solution. This is what? RAY. And this is what? RBY. Now, solution. You are considering, let's do this together, please. Up to the level of support reaction is still the same thing. So let's do this together. What are you going to do from here?
Upward force equals to downward force.
I'm considering summation of vertical forces equals to what? 0. Force of this nature positive, force of this nature negative. Now from here, identify how many force of this nature do you have? Consider your load and your support as forces. Sorry, how many forces do you have generally in this beam? Consider your load and your support as force. How many are they? 4. This is the first one. This is the second one. This UDL, third one. This very UDL, fourth one. What is the difference between these two UDL? The intensity of this is greater than this, right? So meaning I'm having 4 load in general. So that is all this 4 load, I'm considering it here, applying this sign convention. And this sign convention is telling us that force of this nature positive, force of this nature negative. You already know that you convert these two UDL to a point load to something like this, right? Meaning these two guys, it means this, right? Meaning force of this nature. Hope I'm communicating.
Yes, sir.
Alright, let's do that. What do we have? Meaning I have what? RAY plus RBY minus 15 times 3.
Yes.
Okay.
Minus 18 times 5.
Okay, let's do something like this. Let's do this. Me saying, alright, call what do you call for me? Minus what?
15 times
15 times 3 minus
18 times 5.
minus 18 times 5. Let's say this is the first one. Then the second one. Let's say the second one, I'm having RAY plus RBY minus 15 minus 18 equals to 0. Say this is 2. Which one is correct? Between 1 and 2, which one is correct?
1.
Check it very well. Between 1 and 2, which one is correct?
1.
Make your decision strongly. Which one is correct?
1.
You tell me the reason why 1 is correct.
It's 1. 2 is correct.
2 is correct. Alright. 2, 1. Which one? For the last time. 2 is correct. 2 is correct.
1 now.
Alright, let's do it this way. If we say that 1 is correct, why is 1 correct?
Because the
It's
unit
U.D.L. and we're having a point charge, and the SI for point charge is kilonewton. Why for U.D.L. is kilonewton.
Alright. You all are actually correct. It is what is correct. Why is 1 correct? We said that from here, this guy must be converted to this, just because this guy must act at right angle, meaning 90 degrees to the axis of the beam, right? You taking this, you are not following
parallel to the beam.
you are not following the definition of what beam says. You get, but you following this, you are what? Following the definition of what a beam says. Now from here, when converting, you are okay. Let's do it this way. What's the unit of this? W kilonewton per meter. What's the unit of this? Kilonewton per meter. Sorry, kilonewton. W kilonewton. You don't understand. This is W kilonewton, right? We converting UDL to a point load. It means that the unit is going to change. Are you getting me? Please pay attention. This is very, very tricky.
On this thing, it not shows the direction of where the 15 kilonewton is.
It does not.
It doesn't mean. It should make.
I know, but you know, it's only distributed.
Yeah.
So if you want to change it to the point, is it okay? Things we are sitting down.
Alright, back to class. Now from here, hello, this is the unit of my UDL, right? This is the unit of my UDL.
Yes.
And this is the unit of my point load. Since I said that, hello, I'm converting this to this, meaning at the end, the unit of this UDL is changing to what? Kilonewton. Initially, I'm having what? W kilonewton per meter. During conversion or after conversion, your unit must be what? Kilonewton. How do you do that? You simply multiply, converting a UDL to a point load, you simply multiply the intensity of the UDL and the total distance the UDL cover. You know, I'm having two UDL here. This is the first UDL and this is the second UDL. For this first one, identify the intensity and identify the distance. The intensity is what? 15 kilonewton per meter. The distance is what? 3 meters. That's why you are multiplying it together, 15 times 3 for this first UDL. This second UDL, what's the intensity? 18 kilonewton per meter. What's the distance? 5 meter. That's why you are multiplying together. And by doing so, you've converted this 18 kilonewton per meter to kilonewton. You've converted this 15 kilonewton per meter to what? Kilonewton. Now let's see if truly we've converted. From here, let's say you have 15 kilonewton per meter multiplied by what? 3 meter, right? Observe that meter cancel meter. What do you have? 15 kilonewton times 3, which is what? 45 kilonewton, right? Similarly, for the second one, I'm having what? 18 kilonewton per meter multiplied by what? 5 meter. You also observe that meter cancel meter. I then have what? 18 kilonewton times 5, which is equals to what? 90 kilonewton. So that's what we are saying. If this beam was loaded with just a UDL throughout, a UDL of the same intensity, let's say from here, let's say I have 15 kilonewton, let's say I have 15 kilonewton per meter. You know, I've converted. After conversion, I got what? 45 kilonewton. I got 45 kilonewton, meaning in this place, what do I have? 45 kilonewton. And we said for every load subjected to a beam, it must act what? At right angle to the axis of that beam. Meaning this 15 kilonewton per meter has acts at right angle to the axis of that beam, which is this 45 kilonewton. So in essence, it means that if you are giving a load aside from a point load, you must convert. You must convert. You must convert. Are you getting me? You must convert. Any question on that? Yeah. No question. No question. So now, between 1 and 2, which one is correct? 1 is correct. 1 is correct. 1 is correct. Now from here, what do we do from here? Make RAY and RBY the what? Subject of the what? Formula. Make RBY and RAY the subject of the what? Formula. So let's do that. Meaning from equation 1, I have, please let's do this together. RAY plus RBY is equals to what? 135. This will give me what? 45 plus 90. Meaning I have RAY plus RBY is equals to 135 kilonewton. Call this equation. Call this equation 1. Call this equation 1. You can see that the first example we did and this one, nothing changed. Nothing has changed. The only difference is that we converted this CDA to a point load, and we end up getting the same equation 1. Now the next thing is what? Can you remind me what I said initially? Can you remind me what I said initially? That the secret of Shear Force and BMD diagram is that you are implementing a particular principle. You are implementing a particular principle to any different types of problem. You know, for the first one and this second one, you can see that we are already doing the same thing. We are already repeating the same steps, right? Repetition. Now, the next step is what? The next step is what? Free body diagram. No. This is my free body diagram already. Summation of movement about any point. Summation of movement about any point equals to 0. You know, we don't have any horizontal force here, right? So some questions will even come directly, no stress. So you just do this. Now from here, summation of what? Moment. Summation of movement. I said when doing your summation of movement, always write it attract mark, half mark is something. Now write taking movement. You write whatever point you are taking your movement, always write it. Looking at this beam, you know I'm having 3 points here. This is A, this is B, and this is C. At what point should we take our movement? If you take your movement at B, you still get the same thing. It's your choice. Just understand the principle. Now, let's agree on one point. At what point should I take my movement? A. Can I take movement at C? No. Why? Because you have to unknown. I have to unknown. The purpose of me taking movement is that I want to eliminate a particular force out of these two unknown. Let's say I'm taking movement about C. It makes no sense. Just because I'm still having two unknowns. If I'm taking moment at this point, it means I've eliminated this guy. If I'm taking moment at this point, it means I've eliminated this very guy also. Any question on that? No question. Now, you guys said I should take moment about what? Point A. Now, taking moment about point A, right? It attracts marks also. Taking moment about point A. Taking moment about point A. Mathematically, you have this. Now, taking moment about point A, you already know how it works for moment. What's the idea?
Clockwise and anti-clockwise.
Clockwise and what? Anti-clockwise direction. Clockwise and anti-clockwise direction. Now, I'm taking moment about point A. It means what?
You bring all the forces.
I'll bring all the forces to what? To A. I'll bring all the forces to A. Now, your forces, consider your load and your support as your forces. Me taking moment about point A, it means the force at A has been eliminated. True or false? True. Now, if this force has been eliminated, how many forces am I left with? 3.
Yes.
I'm left with 3 forces. This my support. Consider your support and your load as force. This my support 1. This U.D.L 2. This other U.D.L 3. Meaning these 3 forces, which are the U.D.L and the support, they are going to A. Depending on how you want to start, you might decide to start with this one going to A. You might decide to start with this one or this one. Anyhow, just understand how it works. Are you getting me? Now, let's go gradually. Let's say that I'm on 0. I'm going from, what's the total length of this beam? 8. So let's say I'm starting from 0 to 8, meaning I'm going in a gradual process, right? Now, for the first one, if I'm going in a gradual process, I have 3 forces now, right? I have 3 forces. The first force that I'm going to consider will be what?
45 kilonewtons.
What U.D.L? What's the intensity of the U.D.L? 15 kilonewton. Hope we are together. I'm going in a gradual process, meaning I'm going from 0 to 8. Irrespective, you get the same thing. But just to make my calculation easier and neat for me. So I'm going in a gradual process. Me going in a gradual process, what is the first force I'm going to see? I'm seeing a U.D.L. And the intensity of this U.D.L is what? 15 kilonewton per meter. Meaning the U.D.L of intensity 15 kilonewton per meter, I need the force and I need the distance. Why? Because by definition, moment simply means what? Force times the perpendicular distance. So let's say that I have that very U.D.L. I said by moment, force times distance. We already know that the force is what? From our calculation here, the force is what? 15 times 3, meaning I have 45 kilonewton. Now the distance, what is the distance? The distance of a U.D.L is what? Is equal to the centroid. That's what? That's 1.5. That's 1.5. If you are in the last class, you know what we are saying. The distance of a U.D.L is what? Is the centroid. Is the centroid. Is half of the distance. Looking at this, what I'm saying is 3.5. Sorry, what I'm saying is 3. But 3 is not the actual distance. The actual distance is what? 3, it is 3 over 2, which is what? 1.5. So meaning the distance here is what? 1.5. Therefore, the moment of this very U.D.L becomes what? 45 times 1.5. But the question is, this U.D.L, is it going in a clockwise or anti-clockwise direction? Why is it clockwise direction?
Coming to it.
It is going in this manner. Alright, it is coming to A. It is going to A.
Yeah.
It is going to A. It is going to A. If we follow what we have initially, 1, 2, 3, 4, what part is it taking?
1.
Check your book. What part? It is taken for by 4, meaning positive, right? So meaning this is clockwise. This is clockwise. So from here, taking moment at A, I've considered 15 kilonewton per meter, meaning I have what? Positive all into bracket. What do I have? I have 15 times 3 all into bracket 1 over 2 times 3. Right?
Yes.
I've considered this force.
Yeah.
Don't forget, I'm going gradual process. The next force that I'll be seeing is what?
18 kilonewton.
18 kilonewton per meter. Same idea. Nothing is changing. Same thing. Now, if that be the case, that would be what?
Clockwise.
That was also clockwise, right? So let's write it down. I want to see how intelligent we are, how smart we are. Now from here, moment meaning force times distance, right? What's the force? What's the force? 18 times 5. What's the distance?
The distance is 5.5.
The distance is what?
5.5. 2.5 plus 3. That's right.
5.5. Oh, you are wrong. You know why you are wrong? I'm asking that what the distance? What the distance of this CDA? It is 2.5. It is 2.5. It is 2.5. It is not 5.5. It is 2.5. But if I then ask that when taking the moment of this UDL to A, what the distance? You will tell me 5.5. You are correct. No, that's not what I was asking. I said, what the distance of this UDL? You are wrong. 2.5 is the center. 2.5. Alright, now the distance here is what? 2.5. Now the question is it going in clockwise or anti-clockwise? Clockwise. Meaning that by clockwise I have what? Positive, right? Positive all into bracket 18 times 5 multiplied by what? 1 over 2 times 5 plus what? Plus 3. Why is it plus 3? Plus 3, right? This guy, this 5, this UDL, this is the distance. 1 over 2 times 5. But I'm taking movement to A. To A, I'm seeing 3, meaning plus 3. Plus 3. Right? Plus 3. Is that all?
Yeah. No.
I have this force. In what manner is this force going? Anti-clockwise. Positive or negative?
Negative.
Meaning I have negative RBY times what?
8.
Times 8. Which is equals to what? 0. Now I believe you know what the next thing to do from here. What's the next thing to do from here? Solve for RBY. Solve for RBY. So let's solve for RBY. What's the product of these two guys? 45 times 1.5 is what?
67.5.
Please make sure you give me the correct value. Please press your calculator, and I don't want approximation.
67.5.
Alright, now from here, this time this is what?
67.5.
67.5 plus this time this is what? The product of this and this. 495.5. Are you guys sure? 2.5 plus this will give me 5.5. 5.5 times 5 times 18 is what?
Times 90, that's 495.
495, right?
Yeah.
Then this one, what do I have?
8
RBY. It's going to the other side. I have negative 8 RBY. 8 RBY equals to 0. Therefore, the addition of this is what? 8 RBY is equals to, what do you call it? 562.5 kilonewton. From here, divide both sides by what? 8. What's the answer?
70.31.
RBY is equals to 70.31 kilonewton. 31 kilonewton. Call this equation 2. Alright, let's do this together. Alright, now from here, this is equation 1, this is equation 2. Now let's do this together. I want to believe you already know what we are doing now. So it should be easier for us. Just be telling me what to do next. Alright, from here, what do I have? Right, substituting RBY, meaning RAY plus 70.31 is equals to 135 kilonewton. RAY is equals to 135 minus 70.31.
9.
6, 9.
6, 9.
Any question? Any question? No question. Therefore, our RAY, how I love writing mine is that once I've done my calculation up to this level, I'll just say that if the question says that calculate the support reaction, I'm just going to write that therefore the value of the support reaction are 64.69 and 70.31 respectively, meaning RAY and RBY. So your choice. So let's say therefore RAY is equals to 64.69 kilonewton and RBY is equals to 70.31 kilonewton. So this is your support reaction. You've answered question 1A. Now 1B, support 1B, shear force and bending moment diagram. And you know that to get your shear force and bending moment diagram, you need shear force value and you need what? Bending moment value. So meaning I have to do shear force calculation and bending moment calculation. So let's do that. Alright guys, now from here, what's the next thing to do? I want to start a class. Before shear force calculation, don't forget to substitute the two values you've calculated. So what's the value here? 64.69 kilonewton. What's the value here? 70.31. 64 point, what do you call it? What about this place? 70.1. Alright, now the next one is what? Shear force and bending moment diagrams, right? But before you can draw shear force and bending moment diagram, I need shear force value and bending moment value. So let's solve shear force. Let's calculate shear force value. Shear force calculation. Don't forget that I said that probably later on, but not today. Time has gone. We have two methods that we can use to calculate shear force. We do that. Alright, now from here. Alright. Next up, what do we have? Shear force calculation. At A, x is equals to what? 0 meter. What's the value of shear force? 64.69. Bending moment is different from shear force. At A, x is equals to 0 meter. What's the value of shear force?
64.69. Now sleep now.
If it was bending moment 0, right? But now shear force calculation. Listen up, guys. From here, shear force calculation. Shear force says that number one of shear force calculation says that. Check. Number one shear force calculation condition. Alright, now I'm on point A. Do I have any forces behind? No force. No forces behind. So that condition is not working or is not satisfied on point A. Number two value of shear force is what?
Combination of the algebraic.
Okay, let's assume that since there's no force exists behind A, right? So let's assume all the forces that does not exist to be 0, right? Meaning number two value says what? Number two condition says what?
Combination of the forces behind.
Meaning 0 plus the one I'm having on that point. So which one? What's the value of the force I'm having on that point? 64.69. So this is it here.
Yes.
Now the next point is what? At C. What's the value of x?
Let's have view.
This is B. A, B, C. That's all.
Okay, yes, I see.
At C, what's the value of shear force?
The distance is
3 meter. The distance is what? The distance is 3 meters. Now, let's get the first value of shear force. Let's get the first value of shear force.
64.69 minus 45.
Alright, that's correct. I'm on point C. This is point C, right? If this is point C, I'm considering all the forces behind C. I'm having two forces. Don't forget, consider your support and your load as your force.
I'm not supposed to withdraw the diagram. We don't
Okay, do you mean I should withdraw the diagram, indicating it with point load? Okay, let me answer a question. Imagine you are giving 3 hours in exam question, and you have 5 questions to answer. You are going to spend 1 hour on this. Are we done? Now from here. Now, when you are given a question, I love your observation or your question. He said, since we've converted, why can't we represent those U.D.L? What we converted, we should represent it as what? This U.D.L as point load, right? Now, let's say, okay, let's do that together. Let's say I have this.
And then
This is 3 meter. This is 5 meter. This is this will be my point. This will be this intensity, right? This will be at the middle, 15 kilonewton. Sorry, 45 kilonewton. Then this one, what do you think I'm going to indicate this one? Okay.
So
What do you call it?
90 kilonewton.
90, okay. Okay, it's fine. As far as this question is concerned, my recommendation is that, my recommendation for you guys is that understand what you are doing. Don't need to be stressing yourself, saying you want to withdraw it, indicating the point load. Reason is because, let's say in the exam hall, let's say in the exam hall, hello, for instance, let's say in the exam hall and you are given 3 hours, answer 5 questions, calculation question, and you spent 1 hour on this question. 1 hour, just one question, you spent 1 hour. What do you want to do with the remaining 2 hours? So that means, so what I'm trying to say is that many of these time you drawing your diagram, save your time. You need to work smart. Do you understand? Alright, let's continue. From here, at C, meaning x is equals to what? 3 meter. At C, meaning x is equals to what? 3 meter. Now, how do you do your shear force calculation? I'm considering these two forces, right? These two forces, and that was 64.69 and this 15 kilonewton per meter. So meaning my first value of shear force is equals to what? Considering this, what do I have? 64.69 minus 15 times 3. So I have 64.69 minus 45, which is equals to what? 90.69 kilonewton. This is the first condition of shear force. Number 2 condition of shear force says what? Plus the force on that point. But ask yourself, do we have any force on this point? No. Meaning you are moving on. Continue your calculation. What do you say?
19.69.
What do you call it? It won't be 19.69.
That's it.
It will be
Okay, you mean we should consider it to be 0?
Plus 19.69.
Okay, let's do it this way. This is my first value of shear force, right? Number 2 value of shear force says that the force behind and the force on it. But do you have any force on it? No. So we should consider it what? No, you are wrong. If you are telling me that this is the first value to be 19.69, the second value also 19.69. You know, if you want to, okay, that is actually correct. If you want to plot your shear force diagram, you just take one there. But many of you, doing repetition, saying you have this and this. No need. Just work smart. Go with this. Are you getting me? Now, in question, and I believe the lecturer already give you that as an assignment. Let's say you have this. Let's say this is 30 kilonewton. Up to this level, how do I get my second value? It becomes what? 19.69 minus 30. Minus 30. But let's go back to our question. This is what I have.
There's no.
So since I don't have a point load or there's no force there, the next point is what? At what? At B. What is the value of X at B?
8 meters.
8 meters. Without solving, shear force is what here? 0. Without solving, shear force is 0. But let's see if truly is 0. Now, I'm on point B. Behind B, how many forces do I have? 3. I'm having RAY. I'm having this sheet here, and I'm having this sheet here. So let's consider these 3 forces. That becomes what?
19.
That's what? Shear force value.
Minus
64.69
minus 45.
64.69 minus what? Minus
45.
15 times 3 minus what?
19.
And this will give you what? 64.69 minus this time this is what? 45 minus what's the answer?
70.31.
Minus 90, what do you have? Minus 70.31 kilonewton. This is the first value of shear force at this point. How do you get the second value of shear force? Behind, we've calculated it to be negative 70.31, right? On it, what am I having? 70.31. So I have negative 70.31 plus 70.31, which is equals to what? So you solving. Okay, 0 kilonewton. Your choice. So now from here, you can see that you solving a particular question. Hello guys, you solving a particular question for shear force and bending moment diagram. It's something that you can see if you are correct or not. Just because at the end it will end with 0. It will end with 0. Now bending moment calculation. Bending moment. What's that? Bending moment.
Let us finish
bending moment calculation. How do you calculate bending moment? When it comes to bending moment, now bending moment calculation. You already know that when it comes to bending moment, I'll be getting bending moment at each point, right? Meaning at point A, at C, and at point B. Bending moment at A, what's the value of bending moment? 0. Just because bending moment always starts with what? 0. And you know the reason why? I said for our level, the type of beam you'll be giving to analyze, the support the beam will be having is only either pin support or roller support. If it is pin or roller, bending moment always starts with 0 and it always ends with 0. But if it is a fixed support, it can never start with 0 and it can never end with 0. Meaning there is a value of moment at that point. Meaning that if you recall, when we said support and its support system, we said we have fixed support. For a fixed support, we have 3 reactions. We have vertical, horizontal, moment. That moment, that's where it works. Alright, now at what? At A, what's the value at A? 0 meter. Bending moment becomes what? 0. At C, what's the value at C? X is equals to what? 3 meter. How do you get a bending moment?
45 times 1.5.
How do you get a bending moment?
45 times 1.5.
64.69 is going.
Yes,
45, this CDA is going. This RAI is going. This CDA is also going. If you are not convinced, you are not getting it complicated. I'm on point C. Bending moment calculation. You are taking the moment of all the forces behind point C. Meeting on point C, identify how many forces do I have behind point C? 2, which is RAY and this UDL. This UDL. Meaning RAY is going, this UDL is also going. Let's consider this first one, which is RAY. If RAY is going, what is the distance of RAY? 3 meter. Meaning 64.69 times 3. This UDL is going. You need the force of the UDL and you need the distance of the UDL. What is the force of this UDL? 45. What is the distance of this UDL? 1.5. 1.5. Now the question you need to ask yourself is that these two forces, what are their direction? Is it going in a clockwise direction or an anti-clockwise direction? This first one in what direction? This second one in what direction? Anti-clockwise. 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 Any question? Just understand it this way. If you are going in the direction of your clock, you are going in a clockwise. If you are going against it, you are going anti-clockwise. You are going anti-clockwise. So this particular one, imagine you are tipping the arrow edge to C. Me tipping it to C. You can see that you are doing applied mechanics now. Yes. Meaning applied mechanics is a prerequisite course for strength of material. Yes. It's something that you must pass before you do strength of material. Yes. Are you getting me? So let's say you are tipping this arrow edge to C. You tipping it. Go back to the diagram we had earlier. Is it 1? Is it 2? Is it 3? Is it 4? 1. You can see that we are referencing to that diagram. Yes. By 1, is it clockwise or anti-clockwise? Clockwise. So from here, I'm having 60 what? 64.69 times what's the distance? 3 minus my UDL. What's the force of this UDL? 45. 15 times 3. What's the distance of this UDL? 1.5. How do you get 1.5? What's the total value? Give me the total value of this. 126.57. Please, I'm begging you, input your values, calculator very well. The product of all this, what is it? 126.57. Are you sure? Everything, everything. What? 126.57. What will be the unit? Kilonewton. Now at B, without solving, what's the value of bending moment? 0. But let's show our examiner that I know what I'm doing. So let's solve it. Now bending moment at what? At B. What's the value at B? X is equals to what? 8 meter. Yeah, let's do this together now. Let's do this together. That will be what? 64.69 times 8. Alright. Minus 45. Minus 45 times 6.5. Times 6.5. Minus 90 times 2.5. Alright, do you agree with me? Yes. From here, this UDL is going to be, meaning that what my force? 15 times 3. What my distance? 1/2 times 3. But I'm going to B. This 3 is just the force of this very UDL. Yes. The remaining distance to get to B is what? 5. Meaning what? Plus 5. Plus 5. I'm done with this UDL. Next up, I'm having this UDL. Same idea. In what direction? Clockwise or anti-clockwise? Anti-clockwise. Minus all into bracket. What's the force? 18 times 5. 18 times 5. What's the distance? 1/2 times 5. Right? Now, input all this. What do you have? Give me the value. Give me the value individually. Like this. This first one is what? What do you have? This one is what? 517.52. 517.52 minus. This is what? 292.5. 45 times 6.5. 6.5 is what? 292.5. 292.5 minus this time. This is what? 225. 225. Input all this in your calculator. What's the answer? 0.02. Approximately what? 0. With this, are we correct? Yes. Why are we correct? Bending moment must start with 0 and end with 0. And shear force must what? End with what? 0. Now, shear force and bending moment diagram.
Nobody touch it. Because it is very dangerous.
How was the last movie? Start going open. They are not seeing that you use it.
The point. The what? Share that point load. What we converted? No. You see it now. This is the U.D.L. You know, I said that without solving, you can just show and BMD diagram.
Yes.
We have been in our next class. We are going to look at it. Yes. Given different types of load, have how their BMD diagram is going to look like. So you saying that just because it's converted, you are not substituting it. You are wrong. You are wrong. Alright. Now from here, this is my diagram.
Yeah.
Shear force and BMD diagram. All I want to do with this is that all the value I've been calculating since morning, all the value I've gotten, I want to indicate it.
Yes.
So the first one I'm going to draw is a shear force diagram. Now take a reference line for shear force. Take a reference line. If this is the reference line, this is 0. Now, go back to shear force calculation. What's the greatest value?
64.69.
60 what? 64.69. All right. Now from here, let's plot our graph. Let's plot our graph. Let's say from here, this is 0, right?
Yeah.
Let's say I have 64. Okay, let's say this is 90. This is 90. This is 90. Meaning this is the positive region, this is the negative region, right? I'm also having 90 downward, right?
Yes.
Now go back to shear force calculation. At A, what's the value of shear force? 64.69. Meaning 64.69, it's going to be between 0 to 90, right? Yeah. So let's say I have 64.69 here. Any value again aside from 64.69. Moving on C. What's the value of shear force there?
90.
How many values do I have there? Just one. And this value is what?
19.69.
19.69. All right. Let's extend this. Let's extend this. What's the value here? What value do I have here? What's the value of shear force here?
0.
At this point.
0. It's coming downward like this.
At this B, how many value of shear force do I have?
1.
It cannot be 1.
It's
Minus 7.
Okay, let's maintain it then. If that be the case, so I have 64.69 kilonewton. Now at C, what do you call it for me? 19. Let's say I have 19.69 kilonewton. Any value on C again?
No.
Moving on. On B, how many value do I have?
Minus 70.31.
Minus 70.31. Don't forget that this is 0 to 90. So 70.31 is going to be between 0 to 90. So let's say I have 70.31 kilonewton. When drawing this line, what did I tell you guys? Respectively. Important, respectively. Now, meaning I'm starting from 0 to what? 60. Tell me those value. I'm going to be joining respectively. I'm starting from 0 to 64.69 then to what?
90.69.
90.69.
70.31.
And to what?
70.31.
70.31.
To 0 back.
And to what? 0. 0. To 0.
Okay.
Now shade. This is positive. This is positive. This is negative. Right. Shear force diagram. Now from here, can you see that? You know, I told you that given a beam loaded with different type of load, there's a regular pattern that particular load, the shear force and bending moment diagram is going to look like.
Yeah.
You know, for point load, we've seen the pattern how it looks like.
Yeah.
Meaning, given a question, I must still have that same pattern.
Yes.
Also, this shear force diagram, it is loaded with a U.D.L. This is the pattern. I must have this pattern, right?
Yeah.
Are you getting me?
Yeah.
But now, in the next class, there's what we call maximum bending moment and point of contraflexion. Meaning, important point in shear force and bending moment diagram. Now, how do you identify? Question says that calculate the maximum bending moment and state the value where maximum bending moments occur.
Yeah.
Now, you guys will answer that. You know, from here, I'm having A to B. And A to B, the total length is what? 8 meter. This is 3 meter.
Yeah.
This is 5 meter. Now, look at this diagram. At what point do you have shear force changing?
At that point.
Let's say this is A, this is B, this is C, this is D. At what point do you have shear force changing?
C.
At point C, shear force is changing sign. It is changing from positive to negative. It is changing from positive to negative. Meaning that at that point, shear bending moment, meaning at that point, that's where you have the maximum bending moment. That's where you have the maximum bending moment. Now, go back to bending moment calculation. What the maximum bending moment here? What is the greatest value of bending moment here? 126.57. You know, by calculation, I'm having the greatest value to what? 126.57. But if I'm telling you that that's not the greatest value, that it is this point, that's where the greatest value is going to occur.
Yes.
It is this point that the greatest value is going to occur.
Yes.
So we are saying that in general, at the point where you have your shear force changing sign, meaning from positive to negative, at that point, that's where the maximum bending moments occur. If you know that, okay, this is where the maximum bending moments occur, first one now says that find the distance. Find the distance. Now, looking at this, the distance, is it going to be greater than 3 or lesser than 3? Greater than 3. This is what you are doing. Say you have this. Section this beam. By the time you section this beam, it is greater than 3.
Yes.
It is greater than 3, lesser than 8. You don't know if it will be 4.5. Is it 4.5?
No.
Is it 2? No. 2 is out of it. Any number lesser than 3 is out of it.
Yes.
So it's either 3.5, 4.5, 5.5, but you don't know yet.
Yes.
How do you know? You calculate.
Yes.
How do you calculate?
Yes.
You section this beam. By the time you section this beam, you will take shear force at that point you've sectioned. So we will look at this in our next class. Are you getting me?
Yes.
So these are possible questions that you can see or you will definitely see in your exam. You definitely see it. They are called the important point in shear force and bending moment diagram. Alright, I won't bother us with that now. I've drawn my shear force and bending moment diagram, right? This is my shear force diagram. Now, bending moment diagram. Bending moment diagram. Let's take this same reference line. Let's take this same reference line. If this is my reference line, say 0. At A, what's the value of bending moment?
0.
0. At C, what's the value of bending moment? 1.
126.57.
Let's say we have 126. What do you call it? 126.57 kilonewton. At B, what's the value of shear force? 0. Any value again?
No.
No value. Respectively, join this point. You know, earlier for bending moment, when it comes to a single load, it gave us a triangle. But in this case, I'm having a parabolic shape. That is, given a beam loaded with different types of load, the bending moment and the shear force varies. the bending moment and the shear force varies. Meaning I have this. And even if you are using graph, if you use your French curve to do this, you'll be having a parabolic load. A parabolic load. Sorry, you'll be having a parabola, a parabolic curve. Are you getting me? So you have this. So try your possible best to have a parabola.
So if you are using U.D.L, you must have.
Yes, you must have this. You must have this. If it is a U.D.L, you must have this. That's what we are saying.
Because the load spread across
Yeah.
the distance. So once they act directly down, you about the curve on the edge. Oh,
Yeah, that's it. That's it. Because we said it will convert. Something like that.
Yeah.
So now from here, I didn't have the idea that my beam, this bending moment is going to be in a parabolic form. Me now drawing something like this. Me drawing something like this. You see that I'm wrong?
Yes.
I'm wrong.
Yes.
So what that means is that you must know, given a beam loaded with different types of load, you must know how the bending moment will be and how the shear force will be. And that will take us to drawing shear force and bending moment without calculation. Drawing shear force and bending moment without calculation. Without calculation. No, not today. Alright, now from here, shade. Shade. What do you have? Positive. Right. Bending moment diagram. So if you have this, you are correct. And you can also invert it by inversion, meaning you have it upside down. But you having it upside down, positive. It is still positive. Upside down, it means structurally. Structurally. But strength of material, what you see in textbooks, you will see positive. So go with either this or this or the other one. So this comes to the end of this very question. We will solve more questions later on.
How is this so long?
Stop it.